Okay, so I'm qualified in two areas, and you might guess they are Agile and security. In Agile, I'm certified as a Scrum Master, a product owner. I'm certified to implement the Scaled Professional Scrum. And most relevant to this talk, I'm certified as an SPC, that is a Safe Program Consultant. I've been certified since the first days of SAFE. I was certified in the SPC 1 framework and in every framework since then. In security, I've got a wide range of certifications, including a CompTIA Security Plus and an ISACA Certified Information Security Manager, or CISM. So with that as background, I'll get started. So talking about SAFE, the Scaled Agile Framework. It is sometimes considered to be the PMBOK of Scaled Agile. PMBOK, for those who are not familiar, is the program manager's book of knowledge. So it's a huge book, project manager's book of knowledge, which project managers will pull the relevant stuff out of. Similarly, SAFE is a massive website. I've never bothered to count the pages. There's hundreds, probably thousands. So every icon you see on that diagram there would be clickable, and every icon will have multiple pages behind it. So hundreds, if not thousands of pages. SAFE works in layers. So it's got between 2 and 4 layers, depending on how you want to structure it. Team and program would be the minimum. Team, program, large solution, and portfolio would be the maximum. It's done that way to ensure that teams can act as if they're just Scrum teams. They don't need to care about all the complexity associated with a large enterprise. So with that quick introduction, I'm going to do a worked example to help you understand, A, what problem is SAFE trying to solve? How does it solve it? When would you not use it? Why would you use it? Questions like that. I'm going to use cybersecurity as a worked example. So why am I using cybersecurity? First, because I'm well qualified in that area. Second, because cybersecurity is quite topical at the moment. A lot of stuff in the news about cybersecurity. And secondly, because security is difficult in an agile environment. We go into the project starting to code almost from day one. Now, at that stage, we don't know all of the design. We don't know all of the implementation details, and that means a lot of the non-functional requirements, including security, aren't fully known. So if I was doing a waterfall project, this would be no problem. We'd do a design phase. At the end of the design phase, we'd do an implementation and look at how we were going to implement. Then we'd sort out the security, the other non-functional requirements, how fast does it need to respond. All of those questions would be defined before a single developer opened a single IDE. In an agile environment, we would have been coding for 3 months by that point. But that means that we start coding not knowing what our security requirements are going to be. About partway through the project, bang, suddenly the security requirements emerge. They come from outside of the project team frequently as a result of some work we've done. And they come well after we've established our backlog, done our estimations, and so on. So how does it get to the team? How is it generated? How does it get to the team? How does SAFE help a team incorporate work such as NFRs that originate outside of the team and outside of the start of the project? That's one of the questions that I want to ask. So after that massive introduction, let's talk about what we want to learn in this session. So question number 1, what problem is SAFE intending to solve? Question number 2, when should I not use SAFE? And question number 3, how does SAFE enable a team to incorporate security or any other work which may originate outside of the project and after the project has started? In other words, how does SAFE enable agility in a large, cumbersome enterprise. So I know that this talk should take no more than 25 minutes. So if you guys want to jump in with questions, don't be ashamed. Don't be worried about jumping in and interrupting me. Don't be afraid. It's all good. Okay, so let's move on from there. Okay, cyber attacks have changed recently, and you guys have probably noticed that. I was trained in cybersecurity, so I certainly know how I used to do it. In the old days, our black hat hackers and our white hat hackers were lone wolves. I would use Nmap or some similar tool to map out the network. I'd scan the network. After a while, I'd know what operating systems were on the network, what ports and services were open. I'd know a heck of a lot about that network by using Nmap or a similar tool. Then I'd go and I'd use Metasploit or some similar tool to start attacking the known weaknesses. And that's still possible. Lone wolf hackers still exist. They're still a threat, but that's not the main game anymore. And we've seen this in the news. These days, what we're looking at are teams that have specialist team members in them. They're attacking our supply chains. They're looking at our partners. They're looking at our dependencies. They're doing all sorts of tricky stuff. Most recently, they've been using malware to attack us using trusted partners. So it's been supply chain attacks. And we can all think of instances where companies that we trust, companies that we use to monitor our servers or whatever, have been used to insert malware into their customer base. And that has been disastrous. And then from there's been ransomware. It's all been a disaster. So that's the new evolving threat. Specialist teams attacking supply chains and partners. That's what we need to watch out for. So let's create a scenario. Okay, let's imagine that we are working for the Sunshine Electricity Corporation, and it's an electrical utility company, and it lives in Sunshine Land. And the people of Sunshine Land may have heard that Darkland, their sworn enemies, have decided to mount a cyber attack against them, and they intend to attack Sunshine Land's electricity grid. So how do we, remember we work for the Sunshine Electricity Corporation, how do we protect our corporation and our country's electricity grid from Darkland's cyber attacks? So first, let's look at the Sunshine Electricity Corporation. Let's figure out how would Darkland attack us. So Sunshine Land is amazing. They use distributed photovoltaic systems, in other words, distributed solar systems, and a distributed battery system. How do we do that? Well, we as a corporation have put a photovoltaic system on top of every roof in the whole country. Every household has a smart meter, and we use those smart meters to balance the grid. We also use those smart meters to track output from every house. I know this is possible because I was on a team once who did it. So they notify any household if their output drops, and they advise them that, hey, your photovoltaic panels, your solar panels, they're likely to be dirty, or maybe there's shade moving across. And in fact, our system can tell whether it's shade or whether it's dirty, because shade is cyclic, whereas dirty is just dirty. The other thing our system does is if an output drops suddenly, then the household is told, hey, you may have a ground fault. That is dangerous. And we are going to take your system offline automatically to make everybody safe. And you go and you get that ground fault fixed. It's dangerous. So the smart meters aren't just being used to balance the grid. They're being used at the household level. Now, similarly, the battery system is the same. We've given everybody an electric vehicle. Our car batteries are then grid connected to form a virtual battery system, and it's controlled by a smart meter also. So This virtual system is used to smooth out any spikes or troughs in the load. For example, when everybody comes home at the end of work, they plug in their electric vehicle, then they go to the air conditioner and turn it on. They go to the TV, they turn it on. There's going to be a surge around 6:30 in the evening, but that's okay. That's when the electric vehicles are plugged in. Those vehicles typically have about 60 watt hours of storage. They've only used a little bit of it because they only drove to work and back or to the train station and back. In the next few hours, they might draw 2 watt hours. So, 2 kilowatt hours of energy. So it's not a particularly big stressor for these systems. These grid batteries, which are fitted into the electrical vehicles, are capable of so much more. So that's how we're going to stabilize the grid. To enable this, we have to have a lot of teams. Now, some of these teams are vendors. For example, we as a corporation don't go out and we don't put solar systems on the top of every house. We have a vendor who does that, the Sunshine PV Corporation. Similarly, we don't maintain all the batteries and install them, and we don't worry about the meters that the batteries go through. All of that is looked after by Sunshine Smart Meters. But the mobile phone-based advisory systems that tell the households how their photovoltaic systems are going and advise them if there's a problem or tell them how much money they're making by using them, all of those are done by our people. So we've got a digital team. They use a .NET and a SQL backend, and they are responsible for both the photovoltaic advisory system and the battery advisory system. As a backend, we've got a CRM team, and they're using a legacy system. They're using a legacy SAP system that handles all the back-end customer details. We've also got a product team. They don't write any code, but they do tell us what products they want designed, what changes they want to the systems, and of course, we've got a support team. So, how do we handle that? Anybody, and I'm guessing many of you have handled situations like this, you know that a legacy system like CRM, we can't just grab a person out of the SAP team and say, hey, we need you to create a cross-discipline team, because SAP is a beast. SAP, there are multiple team members with multiple specialties. Testing is a specialty. Business analysis is a specialty. SAP teams are typically teams of 6 people. Each of them has a specialty. You can't just take one person out and create a cross-discipline team with SAP as one of the disciplines. It doesn't work. Similarly, some of the people are vendors. We can't just take a person from vendor team and create a cross-discipline agile team. So we're in a bit of trouble. Vanilla Scrum does not handle this situation well. We've got multiple teams. You can't form cross-discipline teams. The multiple teams have dependencies on each other. So this is the problem that the Scaled Agile framework is intended to solve. When you've got multiple teams, you can't form cross-discipline teams, and these multiple teams have dependencies, and to get anything done, the teams have to work together and they have to pass work backwards and forwards smoothly without issues. That's when normal Scrum tends to fall apart a little bit, and you need a Scaled Agile framework. So that answers my first question. When do you not use a Scaled Agile framework? So handling dependencies between teams is what the Scaled Agile framework was designed to do, but there's overhead associated with that. There's extra processes. So your first choice would usually be, not always, because sometimes there's good reasons for keeping the teams the way they are. But usually, if you can, you remove dependencies by creating cross-functional teams. But if all of the teams are specialist teams and you can't create cross-functional teams because some are vendors and some have their own specialties, well, that's when you need a Scaled Agile framework. If you don't have that situation, don't implement the Scaled Agile framework. Now, there's a second situation where you do have cross dependencies between teams. Therefore, you've created the Scaled Agile framework. But guess what? There's one team that lives on their own. They never talk to the other teams. They don't need the other teams. They're all happy and good. In that situation, you don't need to put them into an agile release train. You don't need to put them into a scaled agile framework. You can let them just run Scrum. Now, a lot of people don't do that because you've designed your scaled agile framework. You've got your business units, an agile release train is your business unit. Every team belongs to an agile release train, and this team on its own, we're going to damn well fit it into the agile release train because we're required to do that because it's a business unit. No, that's not the way to go. That adds overhead for that team, and that team does not need that overhead. So you need to find a way of letting the team live on their own. Okay, let's move on from that and look at how is Darkland going to attack our corporation. So Darkland has a series of specialists, and they're going to start talking to our vendors. So they're going to take them out for a few drinks, and they're going to say, hey, you know, at work, we've got all sorts of legacy systems and we've got all sorts of problems. And they're going to whinge about this mythical work they belong to. And they're going to encourage the Sunshine PV people and the Sunshine Smart Meters people to bitch about their work. And they're going to hear all the problems, and they're going to find out what the vulnerabilities are based on what they hear. Now, they can also use open source tools. There's a tool called Harvester, for example, that just goes to the web. You type in whatever you want to examine, and Harvester comes back with lots and lots of links, lots of data about whatever your target is. These two techniques are amazingly fast, amazingly easy, and they give reports on vulnerabilities very quickly. Within a fortnight, Darkland is going to have a report, and the report says that they've found 3 vulnerabilities. So the vendor, the Sunshine Smart Meter Company, has teams that use laptop PCs in the field. They use them to run a maintenance application that records maintenance, battery locations, capacity, all that sort of stuff, and they upload it to the Sunshine Electricity Corporation's FTP site. Now that's fine. Sunshine Electricity Corporation's FTP site is secure, so it should be fine, right? But no, the laptops PCs are old. They're easily compromised. So this is bad. Very, very quickly, our bad guys compromise these old operating systems, and lo and behold, they've now got access to our secure FTP site. It's secure, but it's not secure from our own vendors. And our own vendors are running legacy systems. Similarly, our digital team are running some systems, but the photovoltaic advisory system has an ancient password change page. It is old. It doesn't use .NET. I mean, it goes back to the dark ages. There's never been a reason to change it, so we didn't change it. And of course, it's vulnerable to SQL injection attacks. So anything that goes into that SQL injection attack will automatically update the digital database, and of course that will flow straight through to our legacy SAP database. So that's bad. That's very bad. Notice I've used the word legacy a lot. A question we should ask ourselves is, supposing we were using the .NET Core or ASP.NET with a SQL backend and D365 as our CRM, could we run a SQL injection attack? And I'm guessing you guys know the answer to that. The answer is no. Secure by design. I am not aware of any way that I could run a SQL injection attack on that stack. It's only when you've got legacy that you've got problems. Now, there's a third vulnerability, and it's an interesting one. It's a physical vulnerability. And again, I know it works because it's been done. If you simply take a transformer and knock it out of business, and then go to the next transformer and knock it out of business, and go to the next transformer and knock it out of business, you can create a cascading collapse in the grid. The grid will have to close itself down to protect itself. So our bad guys have found 3 vulnerabilities. What's their plan? So how are they going to knock out the transformers first? Well, that's easy. The way that it was done is a bad guy took a sound-suppressed rifle and shot the transformer. Turns out that if you shoot a transformer, it goes down. It's something you can do quite safely, at least for the guy doing the shooting. So they've decided they'll take a couple of people from their special forces, knock out a couple of transformers. Meanwhile, the SQL injection attack will be used to tell the system that all the PV systems have just dropped to 0 output. We know what that will do. That will mean that the system thinks there's dangerous ground faults, and it'll automatically take everything offline. This will destabilize the grid, of course. Meanwhile, our virtual battery system, we know, is going to be used to stabilize the perturbations. But we're going to update the FTP site and change the addresses of all the battery systems. And that way, when they try to correct the perturbations, batteries will come on place in the wrong areas, won't come on place in the right areas, and the cascading collapse will continue. It'll actually make it worse. So that's our plan. Now, back to the Scaled Agile Framework. How can the Scaled Agile Framework help this situation? So the first thing the Scaled Agile Framework looks at is funding. SAFE funding is agile. That means that SAFE funds teams. It doesn't fund projects. And that's really something to wrap your head around. What SAFE says is it says, we're going to take a team and we're going to keep them together. And we're just going to keep feeding them small pieces of information or small pieces of work in a continuous stream. Now, those pieces may add up to a project, but we haven't funded a project. We're just funding tiny, tiny pieces of work and saying there is a business case for this piece of work, go ahead and do it. And each piece must have a business case. So that means that if we change our mind about something, we don't have to stop a project. We can just say, hey guys, stop. And that's the end of it. Keeping the teams together is really interesting. I guess all of you guys have worked in teams, and you get put together in a team, and yeah, there's a little bit of argy-bargy, and people say, oh, you know, you're not doing it the right way, and so on. Gradually, you form into a team, and then the team really hits its groove, and it's great. And you deliver the project, and the team gets broken up. And you get put in another team, and there's argy-bargy. Well, imagine that doesn't happen. Imagine the team stays together and it hits its groove, and it just keeps hitting its groove, and you just keep being fed work. That's how SAFE works. It's a bucket of fun. So this agile funding means that very rapid changes in priorities can be enabled. So when the executives in charge of the Sunshine Electricity Corporation find out that they're going to be the target of a cyber attack, they don't need to cancel all the projects everywhere. They just need to say, guys, finish what you're doing. 2 weeks from now, you're finished. Right, let's start this new priority. It's very, very quick. Interestingly, vendors are also part of the team. So SAFE has a series of synchronizing events, and one of the big ones is called PI planning. So at the beginning of every 12-week planning period, we have PI planning where everybody is brought together, including the vendors. Now, if cybersecurity has been made a priority, then there'll be funds made available immediately, and they can go straight to the vendors. That needs to be enabled by agile contracts. Anybody who's ever worked on a contract knows that contracts aren't easy. So imagine an agile contract. An agile contract says, you're going to do some work for us, vendor, and we don't exactly know what that work is, but we're going to tell you later, and you're going to be held to it. That contract is hard to write. Yeah, I've spent, on occasions, 3 months working on agile contracts. But at the end of the day, if you've got your agile contract right, then during PI planning, the architects can come along to the vendors and say exactly the same words as our bad guys said. Hey guys, we know that we've got all sorts of problems. We're sure you guys have problems too. Tell us your pain. Tell us your problems. And since it's the team members there, not management, the team members are going to say, yeah, we've got these legacy operating systems. They're so out of date. And from there, we can start doing something about it. As part of the Agile contract, we can work out a way of fixing that problem. So I've talked about synchronization events. It's interesting that the synchronization events more or less mirror what we do in Scrum. So let's look at the inner circle here, or the inner oval, and go to the left-hand side. You can see iteration planning. Everybody who's ever done Scrum knows that iteration planning is pretty much the first thing we do at the beginning of a sprint. We figure out what we're going to do during this sprint or during this iteration. It's generally about 2 hours, and the process is the product owner says to us, here's the work I want you guys to do. And we look at it and we size it and we go back to the product owner and we say, yeah, sorry, it won't fit into 2 weeks, but here's what we can do. And the product owner talks about it. There's a little bit of replanning, and then we decide what we can do in that 2-week period. Okay, that's iteration planning. Now let's go to PI planning, which is just to the left of iteration planning. That's the scaled up version in scaled Scrum, or in the scaled Agile framework in this case. PI planning plans a 10 or a 12-week period. Now, PI planning is where your vendors come in and your architects come in, and your architects talk to your vendors and say, hey, we got a problem, you got problems, let's talk. And we figure out our dependencies, we figure out our plan. PI planning takes 2 days. So I mentioned there's overheads associated with scaling Agile. You don't want a team coming into PI planning if they've got no dependencies, because they're about to waste 2 days. Now, working around the circle, excuse me, there is daily stand-ups as part of Scrum. There's Scrum of Scrums in the scaled up version, and the product owner sync in the scaled up version. As part of Scrum, we do iteration reviews. As part of the Scaled Agile framework, we do systems demo. So again, all the way around the circle, you'll find for every Scrum activity, there is at least one Scaled Agile activity, and it mirrors it at scale. So that's how the Scaled Agile framework works at a higher level. It simply mirrors what would happen in Scrum. So it's a philosophical approach based on Scrum. So there are quality of processes associated with SAFe. And in fact, SAFe is very, very big on quality and on building quality in. So when we go to PI planning, as I mentioned, the architects will go in and they'll talk to our vendors and to everybody else. The interesting thing about SAFe is that the architects have an equal place at the table. So when business sits down, I know as an ex-architect myself, I used to always whinge, oh, business don't give us the time and money we need to build the robustness we need. In SAFe, the architects have an equal place at the table. They talk at the same table as the business, and they say, we need this for robustness, and they get an equal voice. So when they surface a priority and they go to the table and they say, our vendors have legacy systems, and this represents a vulnerability to us, and the business goes, well, that's not our problem. The architects can say, yeah, it is, because they can pass the problem straight to us by passing malware straight to us through our FTP site. So architects get the voice they need as part of the quality processes. DevOps is another huge area. DevOps supports quality processes. So security built in is a concept that is introduced very early on in SAFe. And it starts at the outset, and it starts with DevOps and planning. Now, my fourth point here, and I'll come back to the other points in a minute, but my fourth point is to learn more, you could go to this article, which I provided you. excuse me, it takes a completely different slant from what I'm taking, but I found it very interesting and very informative. I'd suggest if you want to know about security and the Scaled Agile framework, this is a great place to go. I don't know these people. They don't pay me anything. I couldn't pick them out in a lineup. I just found the article interesting. Okay, so let's talk more about security built in. Here's SAFE's DevOps model. So on the top right-hand corner, you've got the beginning, the planning stage. In SAFE, it's called continuous exploration. It's where the architects start doing threat modeling. Now, the architects are obviously doing a lot of other things, but from a security point of view, they're doing threat modeling. Going down or rotating clockwise, excuse me, into the build phase, we're looking at having IDE plugins that do code reviews, static code testing, static code analysis, third-party scans, fuzz testing, and of course, we do code signing during build. So going around clockwise to the next area, we do, of course, penetration testing. Now, if you have done static code analysis, third-party scans, and you've built that into the build server, then when you get to penetration testing, there'll be almost no findings. Now, I'm betting that a lot of you have the experience that I have, that we did not build static code analysis into our build server, that we did not build third-party scans, fuzz testing, and so on into our IDEs. And what happened? The initial penetration testing found 300 critical vulnerabilities. That happened 1 week before we were due to go live. Could we go live with 300 vulnerabilities? No. So what do? We have to delay going live. What is the answer? Security should have been built in, and the Scaled Agile framework enables that by doing threat modeling at the beginning, then straight into building in all of these quality assurance systems. That way, when we get to pen testing, they find one thing, two things. Often they're false negatives, and you just move on. Sorry, false positives, and you move on. Now, the last quadrant, top left-hand corner, release on demand. That's where you've released your code. You're now making sure of stability. So at this point, you've got teams like your incident response team. They're looking at security bulletins. They're looking at security mailboxes. They're making sure that if anything new comes up, we find out about it, and we look at our applications in the context that they're in to make sure that they're not affected by anything new. So this is the model that SAFE presents. This is the model that I highly recommend because it means that it's built in from the beginning and it's continuously monitored. Okay, so getting back to my original questions and closing that loop. My original question was, what problem is SAFE intended to solve? So SAFE handles cross-team dependencies, wherever the dependencies can't be resolved in some lower overhead kind of way. When do you not use SAFE? And I highlighted two areas. When there aren't any cross-team dependencies, or if you could resolve those dependencies in an easier way, don't use SAFE. When there's a team that is independent of all the other teams, even if those teams need to use SAFE, the independent team should not be forced into a SAFE framework. Okay, my next question was, how does SAFE enable agility in large, cumbersome organizations? So I highlighted earlier that SAFE is monstrously large. SAFE basically provides you with a freely available online knowledge base, thousands of pages, and it allows you to apply lean agile practices to the enterprise level. At a philosophical level, what it does is it shields the development process from the complexities. And it does that by abstracting teams away and building the program, solution, and portfolio levels as layers above it. The team almost never sees those layers, but it does provide synchronization points to ensure that the team stays aligned with the priorities at the program, solution, and portfolio levels. And that also means that the team can be very, very agile. It can change directions quickly if that's required. Okay, and I believe that brings me to the end, and I am open to questions. Do we have any questions we'd like to ask?
Yeah, I was checking out. I haven't seen any, but yeah, we'll just wait for another minute or two if we can get. So, David, where are you joining from?
I'm joining from Australia. I'm actually in Melbourne.
Okay.
We're enjoying one of our brief non-lockdown periods. So I've actually
Yeah.
been outside.
Yeah, cool. I'm in Sydney and I can feel it.
Yeah, sorry guys. We did 190 days of lockdown in the last 380, so I know how you feel.
Yeah. Okay, look, so we have not got any question, and I think we will be joined by another person very soon. So Aisha must be joining us very soon. I would like to extend my thanks to you, David, for being a part of this wonderful event. Thank you so much, and it was really insightful. I really hope to see you very soon.
Yes, thank you. It really has been a great pleasure. This is a great initiative that you've started.
Thanks a lot. See
Thank
you. Bye
you.
bye.
Hey Arafat,
Hello. So we will be joined by